Okay, here we are. We're in chapter 10.1. We're going to be talking a lot about exponents, and let's remember what we know so far. So far we remember that 5 squared, 2 is the exponent, 5 is the base, right? This is the base, this is the exponent. I want to be very clear about this because we're going to be really changing things around, okay? But we've done this before. 5 squared is just 5 times 5. It tells you how many repeats, and so that's 25. Okay, so that's like when you have these, your natural numbers, 1, 2, 3, 4, 5, etc. What if we add 0, and we're talking about exponents that can be whole numbers, so now we need to add what happens when we raise something to 0. So we know 5 to the 0, where 5 is the base, 0 is the exponent, but we know that rule is 1, and that's kind of a definition of a 0 exponent. So now we have natural numbers, whole numbers, and we even know what to do already when we have integer exponents. Okay, so integers. And that's the kind of thing we were doing when we had 5 to the negative 2. Okay, so integers are when you include those negative numbers, and you remember when you have a negative number, it means to take the reciprocal, so we're talking about 1 over 5 squared. Remember, the negative sign disappears because I've taken the reciprocal now. And then everything else is the same, and we'll call that 1 over 25. Okay, so that's kind of a nice summary of what we've done so far. I'm going to add a new one to you. We're going to start talking about rational numbers, can be exponents. And rational numbers are anything that can be written as a fraction, so like p over q. Okay, so certainly everything we've done so far is rational, but now we're going to add things like 1/2. So what do you have when you have 5 raised to a 1 over 2? 1 over 2 is the exponent. It's a 1/2 power. Well, I'm not going to split the 5 in half. That doesn't make sense. So let's see what does make sense. If I took, for example, try something. What if I took 5 to the 1/2 times 5 to the 1/2? Okay? These bases agree, right? The 5 and the 5 are the same number. So the bases agree. I'm multiplying them together, so that means I add the exponents, right? That was one of those rules of exponents we had. So this would equal 5 1/2 plus 1/2 is 1. So when I take 5 to the 1/2 times 5 to the 1/2, the rules of exponents tell me I should get 5 to the 1 power, which of course is just 5. Well, that's the same thing that happens when I take the square root of 5 times the square root of 5, and that equals 5, right? So we've sort of come up with a backdoor proof, and I wouldn't call it a proof, but an explanation that 5 to the 1/2 is square root of 5. Okay, so let's take this a little bit further on the next slide. I just figured out that 5 to the 1/2 must equal the square root of 5. And I have another test of this, just to make sure I didn't do something funny. We have more rules of exponents that maybe should shed some light on this. And that is that if I have 5 to the 1/2 and I square it, I know the rule says to take the base and multiply those two exponents together. So 1/2 times 2, which is 5 to the 1. And that's the same thing as saying if 5 to the 1/2 was really square root of 5, and then I square it, I get the same answer. Square root of 25 equals 5. So indeed, this really must be something to this, okay? And in fact, it goes further than that. I can do other roots. And what happens is, if I did 5 to the 1/3 power, that's going to be not a square root, but a cube root. So what's happening is that this sort of denominator becomes the index of a radical. Okay? So anytime you see a fractional exponent, you're going to change the denominator to the index of the radical. Okay? So let's try some examples. What if I had 100 raised to the 1/2 power? What do you think you got? What's the same thing as saying you have the square root of 100? So that would be 10. Okay, so you try. What if you had 8 to the 1/3 power? What would you get? You get your answer and I'll come right back. Okay, so you should have paused it while you worked it out, but basically you're telling yourself 8 to a cubed root. Remember, 8 is nothing more than 2 times 2 times 2 in its prime factors, so when you take that cubed root, you circle all 2 of them, they come out, and you get 2. Okay? So let's see where that takes us. Okay, I can do all kinds of things now with exponents. So I can do lots of different combinations. So say I had an example, 8 raised to the 2/3 power instead of just the 1/3. So now you not only have that denominator, but now you have the numerator as well for the fraction, but the numerator is still raised to a power. Okay, so this is still raised to the power, but the 3 in the denominator is the index of a radical. Okay? So just like 8 squared was 64, I still have that. But what I like to do is 2/3 can be written as 2 times 1/3. Okay? So I have these two different powers. I have the raised to the 2 power and raised to the 1/3 power as well. I choose to write the 1/3 power first, okay? Roots first, because it makes it easier. They'll both work. You can do them in either order, but I'm just telling you it'll be easier if you do the roots first. So I have that one times 2, okay? So remember, that can be written as 8 to the 1/3 and then raised squared, okay? So that allows me to evaluate simply 8 to the 1/3 first. That was the 2, remember? And then I'll square it, so I get an answer 4. Okay? So we probably ought to let you try one of these. Why don't you try 16 raised to the 3/2 power? So give your machine a pause and I'll catch up with the right answer. Okay, I got a final answer, 64. So if you got it, that's great. Go on to the next slide. Otherwise, I'll give it a quick explanation. The 3/2 power up here, okay, that could be broken down into 1/2 times 3. Okay, so 3/2 is equal to 3 times 1/2. So I did the 1/2 on the inside, and then I did the 3 on the outside. So let me evaluate 16 to the 1/2. Well, we all know the square root of 16 is equal to 4, so that took the place of the parentheses, and I still have to cube it, and 4 times 4 is 16 times another 4, because I'm cubing, is 64. So let's try something else in the next slide. I want you to try this one as well. Let's try 25 to the negative 3/2. Gives your machine a pause. I'll be right back. Alright, I got 1 over 125. So let me remind you, this is a negative exponent, and negative means take a reciprocal, remember? So that was the first thing I did. I went ahead and said that's 1 over 25 to the positive 3/2. Okay, the negative goes away when you take that reciprocal. Then I broke 3/2 into 1/2 times 3 with the 1/2 on the inside. Do that first, get your 5. Cube the 5, get 125. So it's still over the 1. So let's try one more. Let you try it. I think you can get it now. Let's try 81 to the negative 3 over 4. Try that one. And I got an answer 1 over 27. So go to the next slide, or I'll give you an explanation. The negative I took care of first by taking reciprocal. So I'm here. Then I decided to break up 3/4. Could be written as 3 times 1 over 4. So I did the 3 on the outside, the 1 over 4 on the inside. 81 to the 4th root. So 81 to the 1/4 is the same as taking a 4th root of 81, remember? So this denominator becomes the index. 81, let's think about it, that's 9 times 9. But I need to find a group of 4, so I'm doing the 4th root of 3 times 3 times 3 times 3. Okay, so now I have 4 of something, so I'll circle those and take it out. So the 4th root of 81 is 3, and I'm going to put that back in over here, and it still needs to be cubed, so I get the 27, and it was still over 1. 1 over 27. Alright, most of the time in algebra we like things to be in exponential form rather than to be in radical form, because all those nice rules of exponents will now be available to us and make things a lot simpler than having these special symbols, okay? Now it's just all part of the exponents, which we've already have the rules for. So here's a problem where they give me a big cube root, a to the 5th b cubed over c squared. And they want me to rewrite this in just radical form. So what I'll do is I'll write the cubed root of 3. We're going to go just backwards of what we've done before. So let me erase that. Whoops, I erased the wrong one, so let me try this. But I think we can go ahead. Sorry. I'm going to write this instead of the radical. I still have a to the 5th b cubed over c squared, but instead of this radical 3, I'm going to write a 1/3 exponent. Now I can use my rules of exponents. An exponent raised to an exponent is multiplication, so this is a to the 5/3 b to the 3/3 over c to the 2/3. Isn't that much better? So, and in fact we can go a little further. I could call this a to the 5/3. This right here, of course, is just a 1, so b to the 1, I don't need to write the 1. And then I could bring the c upstairs by using a negative exponent. So not only have I gotten rid of a radical sign, but I got rid of fractions in my expression. So that's way cool, because you know how much we love fractions. Alright, so I'm going to give you guys one to work on. Let's say you had a cubed root x squared over 8y to the negative 1. And I want you to do the same thing and write this in an exponential form. Give your machine a pause. Okay, you're back, and I've got x to the 2/3 times y to the 1/3 all over 4. If I wanted to write this in a little better way, maybe I'll write it without a fraction using 0.25, x to the 2/3, y to the 1/3. So that way it looks nice and neat. You know, they had that negative exponent in the denominator, so when you bring it to the top, it's like taking a reciprocal, okay? Going from bottom to top, that changes this negative 1 to a plus 1. So, or this changes the minus 1/3 to a plus 1/3. Why don't you try this problem? It's got a whole mix of properties of exponents in it. So give it a try. My suggestion would be to do the negative exponent first, and then make sure you change the symbol radical to an exponent as well. So give that a try. I'll be right back. Wow, that got a lot simpler. I got an answer 2. If you want to hear the explanation, I did do that where I had the negative exponent here. So then I decided that it would be better to change it to a positive exponent and take reciprocal of the inside. So instead of being 1 over, now it's just a plain cubed root of 4 over 1, but I don't need the over 1, so I dropped it. Okay, then I decided to change this symbol into an exponential instead. It's still to the 3/2 power. And then I said I've got this base with an exponent raised to an exponent. This base, exponent raised to an exponent. I need to multiply those two exponents together. So the 1/3 times 3/2, multiply those together by canceling first, you get 1/2. So that's why I have 4 to the 1/2 power here, and of course that's the same as being the square root of 4, and so the answer is 2. Alright, let's see what we can do with this when we're solving equations. So here's an example of an equation, and it's got a rational exponent, okay? It's that exponent written like a fraction. So to do this, we're trying to get x by itself, so we don't want that exponent there anymore. So I'm going to raise both sides of this equation to a 2/3 power. Why did I do that? To undo the 3/2, I need to multiply by 3/2. Oops, I said that wrong. Let me do that again. I need to multiply by, of course, that's going to be 2/3, right? 3/2 times 2/3 is equal to 1. And so then if I have an 1 as my exponent, I'm good to go. So what happens is the left side gets raised to that 2/3 power. I multiply the exponents together. And the right-hand side gets raised as well to the 2/3 power. Of course, this is 1, so x minus 1 to the 1, I don't need the extra 1. 8 to the 2/3, so that's 8 to the 1/3 raised to the second power. X minus 1 is equal to 2 squared. 2 squared is 4. Okay, so we've done that already. Now I'm going to add 1 to both sides. X is equal to 5. And I think that's my solution. But I want to check it because every once in a while, guess what? We're going to have to worry about extraneous solutions, okay? So sometimes that happens here. So we're going to have to check it. Does 5 minus 1 raised to a 3/2 power, does that indeed equal 8? This is my check. So that would be 4 to the 3/2 power. So that would be this 4 to the 1/2 and then cubed. So that's 4 to the 1/2 is 2, 2 cubed is 8, and so indeed I get 8 is equal to 8. Check mark. Good to go. Alright, we'll do a lot of this practice in class next time I see you.